Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome to the Reliability Matters podcast. This is episode number 62. By now, most of us have heard of Industry 4.0 or the Industrial Internet of Things, otherwise known as IIoT, or Smart Factory or Factory of the Future. The key to all of these acronyms is connectivity, data management, material and process control, traceability, and analytics. It's not as simple as collecting data. The data must be understood, useful, and contextual. My guest today is François Monette. He is the co-founder and chief development officer at Cogiscan, a company specializing in track, trace, and control products for the electronics industry. François co-founded Cogiscan in 1999 with two other partners in Canada. François earned his mechanical engineering degree from McGill University in Montreal. François started his career at IBM and worked for contract manufacturers CMAC and Solectron before joining Universal Instruments. Here's my conversation with François Monette. François Monette, thank you for being my guest today on Reliability Matters. I appreciate you being here.
It's a pleasure. Thank you for having me.
So as you recently changed your title, I understand, from Chief Sales and Marketing Officer to Chief Business Development Officer. Sounds like it's on a higher platform there. What's the difference between what you did and what you're doing now?
Well, the only difference really is I used to handle both sales and marketing, and I guess I offloaded the marketing to someone else in the organization so I can focus more on sales, which is really the critical part of our business right now. So.
Yeah, very good. How's the COVID-19 situation landing on your company? I know every company is affected by it. Has it shook you up a bit? Is there a plan B to get all that marketing and business development out there?
Well, there was initially some concerns, of course, like everybody else. We didn't know, how bad it was going to get and how long it would last and so on. We were quite fortunate that the Canadian government had some really good support program for companies like us, and which, in a sense, through the slow months, especially in the summertime for us, they managed to compensate for the lack of, the drop in sales. And essentially, we've made no layoffs. Everybody remained employed. We actually hired a few people even since then. So we managed to go through that, slow period without any damage. And so what happened is, since we were a little bit less busy with customer projects, we're able to invest more time in all of our strategic initiatives, such that we're coming out of this stronger and more ready for the expected upturn now. So.
Yeah, us too. We saw, I think in the beginning of March, my company's in California, so we were kind of the first state to lead the charge of shutting down, right? A few days later, pretty much everyone else did. And when everything shut down, I think the entire industry all looked at each other like, with deer in the headlights, and everything stopped for about 2 weeks. And it was very concerning. I'm sure you were in the same boat.
Right.
It was very concerning. The first 2 or 3 weeks was, what's going to happen. And then I think once the industry realized that this isn't going away, this isn't just a 3-week shutdown, this is going to be around for a while, things just turned back on. And the phone started ringing again. The email boxes started becoming full. The only major difference is we didn't travel anywhere.
That's exactly it.
Not a bad thing,
Bad thing in certain ways, yeah. Although I start missing travel now, almost a year back in the home office, I enjoy traveling and meeting customers face to face. So I'm looking forward to be able to resume that at some point.
Yeah, me too. Even the worst days of travel are starting to sound, it's starting to feel desirable again. We miss what we can't have. So your company is I believe just past the 20-year mark. Is that correct?
Yeah, correct. We'll be 21 years actually very soon. So a milestone that we achieved in 2020. Yeah. Mm-hmm.
Well, here's the big question for you. You started off with 3 co-founders, right? You're one of 3 co-founders. Last I checked, you're all still there. So to start a company, you have to be a little bit crazy. We call that entrepreneur, right? You have to be a little bit crazy. You have to have a very poor assessment of risk, and an eternal optimist. And most entrepreneurs are very independent. we make terrible employees if we were to ever go back into the workforce. So how do three entrepreneur type people start a business? And well, I understand how you start a business. How 20 years later are you still working together? That in itself is a success story. Tell me a little bit about that.
It is a very good question, Mike. And actually, when we started, a lot of people were skeptical about the concept, the three founders, managing the company. And essentially, there was a really flat organization. We were just three founders side by side, although with different areas of responsibility, right? We're all three of us are manufacturing engineers by background. We started our careers at IBM here in Bromo. That's the reason why we're located in Bromo. But Vincent was a bit more business oriented. After doing a master's in engineering, he did a master's in business administration. So he's the MBA guy. So he takes care of the finance and general administration of the company. Andre has always been more of an engineer, more technical oriented. So he takes care of product management, product development. And I eventually left in pure engineering to go into sales when I worked for Universal Instruments as a sales engineer. So naturally, I took care of sales and marketing, right? So we all had different areas of interest, even though we had a common background. And essentially, 20 years later, we still have the same interests and more or less the same split of responsibilities. And I think it's our personalities. Yes, we are entrepreneurs, but I don't think that we're the kind of people that want to do things necessarily our own way. We're team players. We think that the three of us, if we put our heads together, better things comes out than if we were just all by ourselves. So we still believe that very much so after 20 years, and we still get along really well. So I would say that collaboration in that sense is in our DNA. That's the kind of people we are, and that's what allowed us to be very successful with creating long-term partnerships with the equipment vendors and with software vendors, along with our customers. So that's just the way we are. We like to get along, and we like to work as a team and towards a common goal. So
excellent, unusual and excellent. That's probably why you're still around after 20 years when most businesses are gone by now.
We don't mind being unusual, and
I totally agree. If this was a different show, we would dive deep into that. But I'm gonna raise the bar a little bit. Albert Einstein once said that intellectuals solve problems and geniuses prevent them. So you guys are in the business, and companies like yours are in the business of preventing problems, not just identifying, but the end result, end goal is to prevent them. Your company's tagline, and this is not meant to be a commercial for your company, but I find some of the things you put on your website very interesting. Your tagline is making the world better, making a better world through smarter manufacturing. First of all, I love the fact that your goal is the world, right? Which, I always say, in our company, we want to change the world, right? Which sounds Pollyannish, it sounds grandiose, but that's what we want to do. And whenever I see that in a company tagline or vision statement, I'm always impressed. So what is smarter manufacturing, and how does smarter manufacturing prevent problems?
Yes. And you're right. The meaning, it may sound very ambitious to make a better world, but it doesn't mean that we're going to change the whole world by ourselves. But if we can make a small contribution to make the world better after we've been there and after the company was created, that's really the spirit, right? We want to do something meaningful. That's why we started the company in the first place, and that's what we're trying to achieve at the scale that's obviously reasonable for us. So we're very focused, right? We are experts in electronics manufacturing. We cover just one industry alone, and within that industry, we're focusing on very specific area, which is machine connectivity, data collection, track, trace, and control, right? So in that space, we do want to be the best in the world. We've always been very innovative, and we want to continue to be innovative. We want to find better ways to solve old problems, if you want. So I think that's one of our trademarks, and it comes from Andre's ingenious mind of finding simple solutions to very complex problems. So after the fact, it looks very obvious what we're doing and why we're doing it that way. But initially, before we came up with some of these ideas, it was not so obvious. So we're very I guess, proud of that innovation aspect of things. But really, when it comes down to it, we're manufacturing engineers, and manufacturing engineers just want to make things better all the time. Of course, there's always a question of cost. We have to reduce the cost, but quality has always been very, very important, right? You don't want to buy an electronic product and have it fail after a couple of months or weeks. Even more so if the electronics is embedded in a life critical mission like a car or an airplane or something like that, right? So people's lives depend on electronics and for these things to be put together properly. So there's still a lot of manual intervention that happens in the manufacturing floor. And every time there's a human involved, there's a risk of a human error, right? And that includes myself. Nobody's perfect, and nobody. And if you look at the complexity of the manufacturing process, there's a lot of room for human errors. I mean, one very simple example that I like to give, because it's been around forever and it's still there, is when you're trying to set up let's say, a pick and place machine. You have maybe 100 different components, resistors, capacitors, different types of components. They physically all look the same. They get the same shape and size. And to the machine, if you put the wrong component, it won't even be able to tell the difference, right? That's why we're having all these sophisticated systems, with barcodes and so on, to verify that we put the right component, in the right location, so the machine will build the product. But there's still a lot of factories where they rely on people to make sure that they're putting the right parts in the right place. And of course, there will be mistakes, because even if you're very, very good, there's going to be hundreds of components every day that you have to put. And sometimes those components, the part number can be 20 digits, and only one digit is different. That makes the whole difference in the world. So all these little things, is what creates quality issues, creates reliability issues, create waste of time, money, resources. So nobody's going to prevent progress and more electronics to be developed. But if we can do all these new products and this new technology in the most efficient way possible, reduce waste of time, reduce waste of energy, reduce waste of material, we're having a positive impact on the world in that sense.
Sure. You talk about human error. One of my favorite quotes from Donald Berwick, who's a former administrator for the Centers for Medicare and Medicaid Services. He was an appointee of our last president, President Obama. He said, we must accept human error as inevitable and design around that fact. So, human error is not going to go away. We know that our guests don't know this, but when we started the podcast this morning, I was the human with the error, couldn't figure out, your sound wasn't coming through. It turned out I had pushed the button. In fact, the statement I made at the time was, the problem with software is it does everything you tell it to do. And since software is written by humans, it can be problematic. Your products interface with many different types of production equipment, and many times manufactured by companies that may not have IT experience. So your job is to connect someone else's product to a information stream, and those manufacturers may not have any IT experience. So does that present your company with a challenge? That's almost a rhetorical question, because I already know the answer is going to be sure. But how do you overcome those challenges of digitizing, being able to communicate with a machine that was never designed in the first place to communicate outside of its own universe?
Yeah, I would say it's a challenge, but also an opportunity for us, because as you may be aware, about 50% of our business is selling our technology directly to the end users, the manufacturers themselves. But another half of our business is selling to the equipment vendors that embed our technology in their overall portfolio. And as you mentioned, these companies are primarily, their core business is making machines, very smart machines, very good machines. But the IT side of it, the connectivity to the outside world is where typically the limits of their expertise lies around that. And that's where we come in, right? So we have this expertise of connecting different data sources together, different types of machines, which have, the data source could be just a simple text file in the simplest case, or it could be a database that we have to query. It could be sophisticated protocols in some cases. There's really a wide range of sophistication depending on the machine vendor. I would say, there's some really smaller companies that have no clue, what this is all about, and we have some companies, the bigger ones that have very large teams of software developers that are in very sophisticated interfaces. So there's a wide range, and we have to work with all of them. And of course, we're trying to help them. And in many cases, we become their provider of communication interface for the outside world, so they don't have to worry about trying to understand what needs to be done and how to develop it themselves. We do that for them. So this overall topic of trying to tie different pieces of hardware and software together is the challenge that we're essentially tackling here. That was our initial dream when we started 20 years ago as manufacturing engineers. Again, we're not software developers by background. Where we just saw that, hey, there's all these fancy machines, and they all have their own little software functions, and they don't talk to each other, right? So the data is lost as soon as you take a board from this machine to the next machine. Everything is lost, and you have to re-enter the data and reprocess it and get a little bit of data out of that, but in a different format. What a nightmare, And essentially that's the challenge we've been pursuing since then. And it's a journey. I mean, it's much better today than it was 20 years ago. It will be much better 20 years from now. And it will keep going.
That is a very early segue to some questions that I'm going to ask you. But I'm going to wait until near the end to ask you those questions. But I am going to get into what were you guys thinking 20 years ago? What crystal ball were you looking into? Because you certainly saw something that the rest of the world didn't see. But before we get there, let's talk about the things that your company does.
Yes.
There are several steps in the process of implementing a smart factory, Industry 4.0, IIoT, whatever people want to call it. They include, connectivity, which is obviously the most important part, data management, material and process control, traceability, analytics. Let's break those down one at a time. Let's start with connectivity.
Yeah.
Walk me through the steps beginning with connectivity. Do you approach equipment manufacturers? Do they reach out to you, or do their customer reach out? Who's the one that starts this conversation about, I think my machine needs to be connected to the world?
Yeah, no, that's a very good question. And just for as a fun fact, even a few years ago, we were not actually talking much about the connectivity part itself. We just took that as a prerequisite, for the end functionality that we were selling to the customers. Let's say a customer says, okay, I need to implement a traceability system for my customer. Cogiscan, can you please go in and do that? And as part of the putting together a traceability system, we had to connect to the machine. So we did that, and then we provided the end result. Now, what we realized as people were going through the Industry 4.0 and that all these types of topics became more and more important, we realized that everybody was struggling with that machine connectivity piece, and that we will actually develop a very good expertise in doing that. And that's when we decided, wow, okay, this is a business by itself. Either we can be very good at connectivity, but keep all the data to ourselves, or we can try to make that a big part of our business, is to be the connectivity provider and the data provider, in a sense, for any machine, software, or system that needs that data, and really become the leader in that space. And that's been a transition over the past few years to really focus on that. So we're putting more effort. We changed our pricing structure to be able to sell the connectivity as a standalone product, right? So we had to re-engineer a bit the product. We changed the way we commercialize that, and so on. And now that's become our main activity, is to sell connectivity, again, to the machine vendors, to the software companies, to the end users. But that by itself has become a very important product line for us, and a very core element of our strategy. And it is a starting point for any digital transformation effort. First, you got to collect the data from the shop floor before you can do anything else with it. So as people embark into all these initiatives, I want to implement the Smart Factory Industry 4.0, I want to do a digital transformation, whatever they call it, again, they realize at some point, well, first I have to connect to these machines and get the data out of these machines. So it's really the starting point and the foundation for all that. And we think that we have a very strong position in that space.
Yeah, excellent. Let's get into data management. Again, I love quotes. W. Edwards Deming once said, without data, you're just another person with an opinion. And
Mhm.
so data management is described as data integration and contextualization. And I
Yes.
understand the concept of integration,
Mhm.
but contextualization seems to be the primary end result, end goal result. So how does
Yeah.
one contextualize the data so that it's not just one big pile of data?
Yeah, and that's a big challenge that's often misunderstood and underestimated. Let's say that I was able to solve the connectivity challenge. First is to be able to talk to every different machine brand model and so on, and to try to decipher what data is available and collect that data. That's the connectivity layer. Once you get that, you have to bring all that data somewhere in a central location, right? Like a big database where you say, okay, I'm collecting the data from all the machines on all the lines in my factory. And then you need to organize that data so you can understand, okay, well, this stream of data came from that machine and it was actually building that product, using these components, and all kinds of external elements are coming together on the product. So you must be able to track each individual element. You must be able to relate that to the data stream coming from the machine, so all the connectivity piece. And you need to put that in a context of, hey, this board was in that location at that moment, and this is exactly what happened at that time, right? So building all that, the relationship between the materials, the product, the machines, and the environment, the operators, and so on. That's what we call, the data management is part of that. But it goes beyond just those centralizing that data, if you like, and contextualizing that data. I'll give you another example. Some machines are able to read the serial number of the board as it comes through the machine. Like inspection machines by default will be able to read the barcodes, right, and tell you that this is serial number XYZ, and these are the result of the inspection that go with it. So when you connect to the machine, you get the data that's already contextualized, at least to know which product matches the data stream. Other machines don't have that capability, depending on the machine brand model, what options the customer has purchased. Did they buy the traceability option or not from the vendor, and so on. Sometimes we just get the data stream, but we don't know which board was actually going through the machine at the time. So we have to be able to put additional hardware like barcode readers and so on, and different things around the machine to capture the serial number of the board, and through timestamps, equate or associate the data from the machine with the product that was actually in the machine at the time. So that's also part of contextualizing the data that we get from different sources and putting it all together. On top of that, then you have to be able to collect very vast amounts of information in real time without slowing down the line in the machines, being able to store that data very fast, and then being able to retrieve that data very fast once you need it, because you need to run a report or you need to create a dashboard. And that's because we're talking about very vast amounts of data. This is really also very challenging. So all of that complexity is hidden under the data management space, but there's quite a bit of technology there as well. So the connectivity is the first piece, but the data management, I would say, is probably the most complicated element of all this.
Yeah, I would think so.
Mhm.
To make sense of that data. Otherwise,
Yeah,
it's just data, right?
that's it,
There's
and it needs to be structured and organized. It's not like one database and one table. That same data must be processed and stored in different ways for different purposes. If you're going to run a traceability report, it's not the same as if you're trying to do a real-time dashboard, for example, or you're trying to run some SPC or advanced analytics. The data must be structured differently, because the data, again, is not just for our own use, it's for any other system that wants to access that data. So it could be the ERP, it could be an MES, it could be an artificial intelligence algorithm that requires data, and they all require different structures of data access in different ways. So again, that's a very complex topic.
right. The contextualization has to be put into context itself, right?
That's
Who's
right,
looking at the data?
exactly.
So I would imagine there's probably some scenarios where the manufacturer of the equipment is collecting certain bits of data which they feel would be not relevant to anyone, but someone three steps down the line might find that data helpful. So,
That's
so
right.
I that
And it's a never-ending journey, right? I gave you the example of inspection machines that in the past it was good enough to connect to a machine to know, okay, which serial number of the board was inspected. Is it a pass or a fail? And maybe collect some defect codes, right? Okay, I got the defect on C51 and so on. And that was enough, to do traceability and to manage the flow of the repair and so on. But nowadays we want to collect, actually, some customers want to collect every single measurement or attribute that was collected from an inspection of one board. And it can be up to 50,000 measurements or attributes on one single board. That's a lot of data. And then on top of that, they also want to collect the images. They want to keep the image of the board inspection and the defects and so on. Maybe not forever, but they want to keep that information stored somewhere for a period of time as well. And you can imagine, again, the challenges associated with storing very complex, heavy images for a period of time on machines that are pumping boards every few seconds. So,
sure.
Yeah. Mm-hmm.
So I'd imagine at some point, TMI, too much information, is a concern. And I think there's probably two types of customers that you have, just knowing human nature. One that just wants more data, the more data, the better, because they're just data geeks and they geek out over all those numbers. And the end result, though, is the data has to be helpful. So too much data, you drown in helpfulness. So is it your customers? Is it you? Is it a combination of opinions and consensus that determine what's enough data, what's too much data, what's too little data? Some people want a dashboard, green, red, right? Just green, red. Yeah. Tell me go, no go. Tell me to worry, tell me not to worry. Some people want all the numbers behind that green or red. How do you differentiate that?
It's really up to the customer ultimately to decide. And again, it's a journey, right? So I think everybody realized that, yes, we all dream about having artificial intelligence that, some kind of big brother that watches everything that's happening in the factory and can analyze all the trends and automatically adjust the equipment before something goes out of spec, right? But we're not quite there yet. So as a matter of fact, there's different levels of sophistication, you're right. And depending on the output, what function the customer wants to be able to implement, what system he wants to be able to implement, that dictates what data we need to collect and provide from different machines. So it's really, and again, it's going to probably be a little bit more every year. They're going to implement more applications, more systems that will require more data and so on. So again, it's a journey from the customer side as well as on our side. It's really gathering, but there's always going to be more data to gather and more applications that will take advantage of that data over time. It's a little bit like the dilemma with the computer, personal computer performance versus the software running on that computer, right? If you think you come up with a box that can run the existing software so much faster, you'll never need anything better. Well, Windows will come along and give you more software that will slow down your machine until you need to. It's similar. I mean, the more data you get, the more data you want, and the more data you can use. But it's a gradual transition.
I think this is true. Maybe it's an urban myth, but I think this is a true quote. Bill Gates once said, quite a few years ago, he can't imagine a world where anyone would need more than 640K of memory, right?
Yeah.
Look at us now.
It's progress, right? It's technology and progress are two things that are seemingly unstoppable, and I think that's what we're seeing. I mean, the factory of the future will always remain the factory of the future, because there's always more you can do. There's always more automation. There's always more data to be collected, more analysis you can do, and that will remain true for as long as I can imagine.
Sure. Yeah. There will always be a factory of the future. Yeah. So we talked about connectivity, data management. Let's touch on material and process control. Explain to me what importance material control, process control have, and what issues are we trying to solve with that?
Yeah, no, for sure. If you don't mind, I'll just want to draw a little comparison between the material control and other, what we call the track trace control applications that we offer relative to the connectivity and data management layer. Okay, because again, I explained, I don't want that to be too much Cogiscan centric. But the fact is that Cogiscan, again, I mentioned, we're very focused. We have a narrow focus on some certain areas, and we don't pretend that we're going to be able to solve all the problems of the world. And I don't think that any company could say that the smart factory will be achieved with just one software system or one vendor. It's not real. It's really it's going to be a collection of different pieces of equipment and software working together to really continuously deliver more and more functionality. So with that in mind, again, the key role that we play is the machine connectivity, the data management, and then open up that data management to the rest of the world, right? It doesn't matter which software needs this data. Our job is to provide the data. On top of that, some customers will have specific needs, and then we have a small suite of applications that can fulfill those needs if they don't already have another system doing that. So material control is a good example. Many companies have software solutions to provide material management because it's a very important requirement in our industry, right? I often like to say that building a circuit board, assembling a circuit board is basically a value-added component distribution business. You're buying all these different components from different companies that are worth a lot of money, and you need to put them in the right place on the board, and that's basically your job if you're a contract manufacturing doing electronics assembly. So the actual value of the components represents maybe 80% of the finished cost of the product. The rest, the value added of putting the components on the board is actually a smaller cost compared to the cost of the material. So big dollars in the materials themselves. So this task of trying to control those materials on the production floor, making sure that they're used in an optimal fashion, that you know where to find the materials, that the lines are not stopped because one reel is missing somewhere. All that material management is paramount to having an efficient operation. So that's why many companies offer such solutions. In some cases, the machine vendors themselves will offer material management software. In some cases, some of the MES and ERP systems have material management. We also have it. Ours is highly specialized for electronics, and I would say it's machine vendor neutral. So because of the nature of what we do, we connect with, sometimes for example, the pick and place is from vendor A, but the storage tower, the automated storage tower, which becomes very popular now, is from a different vendor, right? But they have to talk to each other because when the feeder is running low, the components are running low in one feeder slot, we want to be able to send a request to the storage tower to prepare that reel because we're going to need it an hour from now, right? So that kind of integration, handshake, and communication between the different pieces of equipment, that's the kind of thing we do. And so we offer a complete suite of material management solutions for that.
Yeah, excellent. Let's get into traceability.
Mm-hmm.
I can think of a couple of takeaways from traceability, which might include recall management, to know if a part was bad, know where those parts went, which serial numbers they're in, and which can lead to obviously improved dependability and reliability. Review those key traceability takeaways and other benefits that come with traceability.
Sure. Yeah, in the past, the traceability was really viewed as like an insurance policy for the large OEMs, that are selling complex, expensive products, and sometimes there's going to be some recalls to be made. So if you have a good traceability in place, you'll be able to identify the root cause of the defect and really narrow down the range of the products that you have to recall, right? So which will have obviously the cost savings and also the brand image impact of having to recall fewer cars or whatever the case may be. I mean, imagine doing a recall on pacemakers, for example, right? So in some cases, it's so for that reason, industries like automotive, aerospace, medical have always had strict requirements for traceability, but it was just that. It was an insurance policy to try to minimize the costs and implications of defective products in the field. And then it started to spread to more of the consumer products, like the smartphones. And it's not because these products are life critical, but it's because you sell so many of them that if indeed there is a defect and you need to recall, there's a huge difference between recalling 1 million units or recalling 10,000 units. So it's a cost issue again associated with that. So that was the initial driver for traceability. I would say now that we're thinking more globally about smart factories and Industry 4.0, I think people realize that traceability is actually only a natural byproduct of a good tracking and control system, right? So if you're trying to make sure through automation and software that the product is being built the right way in the first place and that you eliminate human errors, well, if you just register all these events that are need to be controlled by software through barcode scanning and things like that, and the data you collect from the machines. If you just store that in a historical database, then you end up building a very complete traceability history database without additional cost, if you want. It's just, again, a byproduct of a good software system in place. And then once you have that data, you can analyze that data to see, okay, well, I'm seeing some trends, there's so many defects always happening, and where those defects come from, and then you can troubleshoot, identify root cause, and improve your own efficiency internally. So it's not just for your customer anymore, it's for your own cost savings and quality improvement and so on that you want to gather and analyze that traceability data. So.
Yeah, very good. Analytics. We're making our way down the list here. Analytics. The dictionary describes analytics as a systematic computational analysis of data or statistics, which brings me to another quote. Mark Twain popularized. He didn't write this, but he popularized the following: there are three kinds of lies: lies, damn lies, and statistics. So we always have to be careful with statistics. How do analytics and statistics play? How do they work to improve reliability and efficiencies on the factory floor?
Yes. Well, analytics is a way to look at a very large amount of data and try to make sense out of it, right? As you indicated, if you collect all this data from every machine, no human being can actually go through that and figure out what's going on. So if you start doing basic statistics like averages and percentages and things like that, it's already a good first filter to figure out what's going on. And then you can start charting those key measurements, or KPIs graphically, so you can see if there's a trend or if it goes out of limits or things like that. So very quickly you can just calculate some basic numbers and so very simple analytics, and that becomes very useful. So in our case, we have we kind of draw the line between the real-time analytics. So this is to display a dashboard right on the line for the operators to see how his line is running in real time based on different key parameters, and if there's anything that goes out of whack, then he gets right away a notification, and he's able to drill down to the root cause and again correct the problem before it gets out of hand. So that's the real-time part of it. And through technology today, the operator can see a big screen on top of his line, but the supervisor in his office can see the same charts, and maybe the plant manager who's playing golf is able to see that on his phone at the same time if he wants to. But it's really about visibility, monitoring your operation and making sure that everything is under control. The next layer is really more into being able to drill down in the historical data once again, where it's similar to traceability but a bit more advanced, because now you're not just pulling the raw data, but you're also trying to analyze that data to see where there seem to be some trends. With this product, we're not doing as well as the last time we ran that same product on that same line. So what's changed and where are the areas again for improvement? So that's only basic analytics, and that's what we typically offer ourselves. But there's so many more layers of analytics that we plan to develop ourselves. But many other companies have such analytics tools. Some are part of the business intelligence, BI type of category of tools, and AI more and more, deep learning. So there's a ton of companies that are really good at doing data analysis. And again, in that case, our job is to provide the best possible data out of the shop floor, and in some cases, provide the domain expertise, because an AI company may not be able to understand where does the data come from if it's electronics. They're not experts in electronics manufacturing, so they don't know what this data or that data piece really means and what are the interactions. That knowledge, that know-how we can provide to these companies. So that's why we work more and more with software companies that they can take their algorithms, their really smart data analytics tools, and bring that into our industry, and we help them connect to the data, and we help them make sense of that data as well, so that their technology can be leveraged. So in that sense, I think we're going to hopefully help a lot of software companies that are not specialized in electronics come into our world over the next few years, and that will really change the landscape of the vendors. We used to see always the same few companies in our industry, but I think this will change quite a bit as technology, comes from all different angles, all different industries, and somehow we're there to facilitate their access to our industry.
Oh, that's terrific.
Mm-hmm.
Which kind of brings me into Industry 4.0. We've been talked about Industry 4.0 for years, right? You and I both have heard Industry 4.0 being batted around for a long time. It's spent a lot of years in the theoretical, and it does seem to now be in the practical. What's the status of Industry 4.0 or whatever other acronyms are being flown around for that same descriptor?
Yeah, I mean, I like to think that Industry 4.0 is just that. It's a term, right? That was invented by someone at some point to describe, what should be the next goal, towards again a continuous journey of progress and technology, right? Personally, I don't see a big difference between Industry 4.0, smart factory, digitalization as to what we've been doing for the past 20 years. When we started the company, we said, hey, a lot of manual stuff is still going on, a lot of room for human errors, a lot of data is not being collected, analyzed properly, right? And then we just need to use the existing technology. It's funny because our industry creates the most advanced technology, but we're not using the technology sometimes to improve our own operations, right? So we said, hey, there's so much we can do. I mean, I remember 20 years ago, we were really into RFID, and we said, wow, we can bypass the barcode and go the next step where every day all the data will be collected in real time with nobody even knowing that the data collection is taking place, because RFID allows us to do that. I mean, 20 years later, we still work a lot with barcodes, and we also interface with smart machines and so on.
Well, as the saying goes, the cobbler's children have no shoes.
That's true. That's true.
That seems to be applied.
The point is that for us, it's a journey of trying to gradually improve how we do things using technology, and it's just, again, technology being applied to solve problems in real life in the electronics manufacturing world in our case. And whether you call it smart factory, Industry 4.0, it's on that continuum for us, So it's all important and great if these programs or these terms allow people to better understand where we should go and why we should do that. That's great, but quite frankly, for us, it's just the same thing that we've been doing for 20 years, and we plan to continue doing for the next 20 years. Yeah.
Excellent. It seems like the problem with the name 4.0 is you think by now we ought to be at least 4.1, or 4.2, or 5 even. Anyway, we seem to be stuck on that number.
But that's also the basic flaw of these programs is it sounds like you have a starting point and you have an end point, right? Where eventually you're going to achieve this and then you'll be done. But I don't see it that way. I think it's a journey that will never be finished. So
I agree.
But again, whatever works, it's okay with me.
It's progress. Yeah, it's constantly moving. Sometimes slow, sometimes fast. So when I was a kid, I used to watch a show, called The Jetsons, which was the family of the future that lived in something floating in the air, and they went to work in sky cars, that can fly through the sky, and they had robots cleaning their house. And I used to read Modern Mechanics and Popular Science when I was a kid. And, I remember by the year 2000, this is what, society would look like. And again, we had flying cars and houses floating in the air. So there's always been a myth of what the future will bring. And then the reality of what the future will be. And I keep that in mind when I read more and more now about so-called lights out factories, right? So, factories with no real need for human intervention. They're just stomping out products, with no lights. How is that a Jetsons, thing that will never actually happen? And does your company, is that a goal within your company? Do you have clients requesting something closer to a lights out factory? And in our industry, is that even a practical goal?
Yeah, I mean, I'm not an expert on other industries. I think some industries are probably easier to fully automate than others. Ours is a bit challenging for different reasons, not necessarily on the software side, more on the mechanical side of things. I'm thinking about a very simple example of loading a reel into a feeder, right? depending on the machine brand, the feeder's design is different, but the reels are all pretty much similar. But you always need somebody who's going to peel the cover tape, insert the reel, slide the tape through the right, and then eventually index that and make it ready for the machine. That part, to automate that part, to me sounds very complicated. It doesn't mean that it will not happen, or maybe some companies are already working on trying to find a way to completely automate that manual process, but so far it hasn't been achieved, let's say. However, we've seen other parts where there was great progress. I mentioned earlier about the automated storage, right? I didn't see that coming a few years ago, and now it's very prevalent. I mean, if you think about, being able to put a bunch of reels, you put that into a bin, and then somehow they all get stored automatically, and then when you need them, they're going to be dispensed automatically. That's pretty impressive, right? And that's a higher level of automation than what I even expected to happen in my lifetime to some extent. And now they're taking that one step further with the small AGVs that can take a pile of reels from the automated storage system and take that directly up to the line, right? But there's still going to be a human to pick up those reels and again load them on the feeders manually. So that's just one example, but I think today it's not really practical to achieve lights out factory. It has to be also economically viable to do it, right? So maybe if we put enough money, like we can go to the moon, so we can put enough money, we can have lights out factory, but is it going to be financially viable to do it that way? If it's cheaper to hire people to do it, that's what the industry will do, because cost is always very important. So I think there's going to be continuing progress. Again, whether it's going to be a real lights out factory at some point, I don't know, and I don't know when, right? So I'm not going to try to guess that. But what customers are typically asking us today, and what they're trying to do, is certainly to reduce the number of human beings needed, number of operators needed to run one line, or maybe they want to have eventually one operator for two lines, and try to minimize what things need to be done by a human, and everything else should be automated. So I give the example of the automated storage, transporting the material. If you do that automatically, you eliminate human beings, operators, and then and that's financially viable right now. So
sure,
that's my perspective on the lights out factory. I don't know if it's going to happen or not, but the idea is, again, it's on that continuum of trying to add more automation as long as it makes business sense. Yeah.
Sure, I think selective lights out, but obviously in our industry, we're putting. I think there's a need for a little bit of light in our industry.
Yeah, so far, yes.
Yeah. Yogi Berra once said, and if you're familiar with his quotes, he's always very understated. You can observe a lot by watching. 20 years ago, when you and your two partners founded your company, what were the observations that led you to form that company? No one was asking for Industry 4.0 back then, right? At least not by that name. So what did you see that maybe others didn't see? That you created a product. Did you create a product without a need, or was there a need that you created a product for at that time?
It's a great question. It's a funny story as well. Actually, what we did is first we decided we wanted to start a company, okay, without any idea for the product. Almost that. No, it's not true. But one of the founders, Vincent, after doing his MBA, he was still working for IBM at the time, but he had this, ambition of starting a company, and he said, okay, it should be in our industry. This is what I know. This is and he came up with one idea for a product based on his experience, and then he started working towards that, putting together a business plan to start a company based on that one idea. And then he approached Andre, because Andre and Vincent and I used to work together at IBM, but also later on we moved on to different jobs. And at one point, I was working for Universal Instruments in sales. Andre was working for Universal Instruments, but in the technical role back in Binghamton. And Vincent was still at IBM, but he was in charge of the group buying the machines from Universal, right? So that's how the three of us got to know each other a bit more. And I think Vincent had a really good confidence in Andre's technical expertise, and so we went to him and said, hey, I want to start a company, and here's the product idea that I have, and I'd like to know what you think about that. And Andre said, well, I don't know about your product ID, but I would like to start a company too. So if you're looking for a business partner, I'm in. And so I said, okay, well, come on in. So the two of them started talking, and at some point they said, it might be nice to have somebody who knows something about the business side of sales and things like that, because they had no experience on that front. So they reached out to me, and I said, yeah, I've always wanted to start a business as well, so I want to join you guys. So we started to look into the original idea that Vincent had, and for different reasons, decided that was not exactly the right fit for us. It required too much investment, too much time, to come up with the first product. So, but by that time, we were, sold on the idea of working together and starting a company together. So we said, okay, let's look at our industry and let's try to identify some problems that are not solved today that we think we could solve. And that's through that long-term, very wide view brainstorm, we came up with this basic idea of what we're doing today. And then just by observation, you're right, we had the chance of having a background where we used to be in the business making semiconductor packaging. So we were making components at IBM. And then I worked for a company that was doing contract manufacturing for building boards. So I saw the other side of the industry, the people that are taking the components and putting them on boards. And then after that, I worked for Universal that was selling the machines, putting those components on the boards, right? So I think that perspective helped to identify some opportunities that maybe were not obvious for somebody who did not have a chance to look into the different sides of our industry, right? One example is a very obvious example, and that ended up being our starting point. When you're making components like we did at IBM, you take great care in maintaining the moisture sensitivity and actually trying to design the components to be as insensitive to moisture as possible, right? You don't want the component that's going to have a shelf life of 16 hours on the production floor. That's bad. So if you're making components, you're trying to make them as robust as possible. But the nature of the materials is such that they will always be sensitive, and some will be sensitive at level 3, 4, 5, and 6. But it's a really big deal because your whole business depends on trying to make these components, easy to buy and easy to assemble for the electronics manufacturers. So we're very, very conscious about this moisture sensitivity issue. And once the components are manufactured, they're baked, dry, they're put into a sealed bag with a desiccant, right? And then the big label on it, these components are moisture sensitive. Once you open the bag, you have only 24 hours to go to reflow. If otherwise, it's a big reliability issue, right? So in the component world, this is really clear. And then when I jumped over to the contract manufacturing side of the world, I was shocked, to see, wow, these guys have no clue what is a moisture sensitive component. They open those bags and they throw them in the garbage and they send the components out on the floor. There's no tracking whatsoever. I said, my God, this is unreal, right? And imagine all the reliability issues that this causes. But nobody seemed to be aware of that because the reliability defects induced by moisture sensitivity are typically latent, right? They will come out in the field, and it's hard to relate that to the root cause. So sure. Because they're not obvious, not apparent, it was a big issue, but nobody seemed to care or to know that it was a big issue. So that's one example where it's okay. That's part of the automation that's really lacking here. Between this layer of the world and this layer of the world, there's a big gap, and we have this understanding, this expertise, and we can come up with a solution to automate the handling of moisture sensitive components. That turned out to be our first product, and we still sell that product today. But back then it was like that. So anyway, long story short, that's how we started the company, by basically first wanting to start a company, then looking for problems that were not solved and trying to apply the technology. But of course, we had the fortunate situation is we were not out of a job and trying to start something quick, right? We had already a job. We were able to brainstorm for more than 1 year, trying to anticipate, where do we start? Where do we go next? What's the big vision of things? And then that really helped out afterwards, because it's not like we started out, okay, we're going to invent MSD control, we're going to sell that and then see what happens. No, we already had the roadmap for the future, and to be able to track not just moisture sensitive components, but all components, right? And then to interface with the machines and to be able to do traceability and to be able to do all these other things that we do today. That was already in the back of our mind. So we had a really long-term roadmap, and we made sure that the architecture of our software would support that long-term roadmap. So, so in that sense, I mean, I guess we looking back, we could say we were a bit visionary, but it's just because we took the time to look at it, to look at the world as it was, and to try to anticipate what could be better. And that was the chance that we had to be able to be in a position to do that. So.
Well, again, back to Yogi Berra, it's amazing what you can observe when you look, when you watch.
Yeah.
So in your company, you're the sales guy, right? I know you're an engineer, but you're the sales guy primarily, and and your other founders are kind of the engineering people. I've talked to a lot of business owners, and through personal experience, you need the sales guy as one of the founders, because without the sales guy as one of the founders, you'll just keep engineering products and never bring them to market. At some point, and again, I don't want you to give them any family secrets, but at some point, did you ever have to go up to your team and go, okay, already, this is great, let's release it, and drag it from their fingers and put it out to market, because a lot of engineers, particularly when they have when they're founders, are never quite ready to give their product away, because it could always be just a molecule better than. And the sales guy knows it's nothing if it doesn't get out into the field. Has that been an experience in your world?
Not quite in our case, no. I would not say that. And maybe it's because, again, we have a similar background. We're all manufacturing engineers. So by nature we're conservative people. We don't like to take big risks, and we know that we're like our customers. We used to do their job to be the manufacturing engineers. When you're a manufacturing engineer, you want to improve things. You want to implement new technology, but you cannot disrupt or impact your operations, right? The lines have got to keep running. And if you shut down something because you try to put something that's not reliable, you're going to be in big trouble. So you don't want to do that. So I think we kept that mindset all along, that I don't think we ever went too fast to the market. And I'm not the one who would push to put a product to market if it's not quite ready. No, we never had those kinds of issues much. I mean, in some cases, you think the product is ready, you install it, and then you realize, wow, there's some things we did not anticipate. So the learning curve sometimes has been longer than expected, because on surface things look simple, but when you get into the real life, sometimes it's a lot more complex. There's a lot of little things that we did not anticipate in the product design. So that's why we're very careful now. When we design products, we work closely with our customers, our partners, and then we go through several steps of testing the product and doing through a first pilot, and then if needed a second pilot before we release it across the board. I think that conservative approach has been good for us. We're certainly more conservative than the average software company. If you think about companies like Microsoft, they always they release a software that's full of bugs, but they say, oh, in the next revision we'll fix all that, right? That's kind of the image we have. Well, we're not like that. We're the manufacturing engineers guys who say, no, you cannot put something out that's not going to work, because our customers will be in trouble. So we got to find a way to introduce technology without disrupting operation, and that's always been the key element of our strategy. Yeah.
Sure. In our world, you talk about putting out product and maybe there's a bug in it. In our world, what we didn't anticipate is what the customer would do. And of course I'm exaggerating, but we'll put out a new software rev for one of our machines, and a customer will call and say, yeah, when I stand on my head, wear red socks, and press these three buttons at the same time, the machine crashes. Yeah. Why are you doing that? but we can't test every combination of what a human might do, right? So, and in your world, you not only are you dealing with the human factor, which is which is unstable enough, but you're dealing with a variety of different machines and written by humans doing different things, not without what you're doing in mind when they originally developed it. So I imagine that just complicates things even more, right?
It does. And sometimes I find it funny. It's probably because we're engineers, but we probably tackled the worst possible problem, and put it down on our shoulders, and so everybody else can have it easy. But that's the way it is. And I think in a way it brings a lot of value, because it's truly simple. So for the people who look at it from the outside and never tried to do this type of machine connectivity, data collection, it may look simple, but everybody that's tried it, then they know what it really entails. And then they're very happy that we're there to take care of it for them.
I imagine just as
job security for us. Yeah.
Yeah. Oh, yeah. Job security forever. I would imagine you unwittingly end up cleaning up a lot of other companies' code, because, the way it may be written may not be conducive to you getting that data stream. So you probably have to clean up a little bit of code here and there in order
That's
for
a
your
good
product
point.
to work, right?
Yes. Essentially, when we're talking about the machine interface, it's really a software integration project, right? We're not talking
Right.
to the hardware itself. We're talking to some piece of software that's installed on the machine. So, and sometimes it's even a whole software. So, depending on the machine vendors, sometimes their interface to the outside world is through a host somewhere. So, we're really talking to a computer that's running a piece of software. So, it's a software integration project, and those, of course, the success of that integration depends on both sides. There's only so much we can do. If there's real flaws in that interface, we can work around it somehow, but there's a limit at some point. You're right. The key to our success is that customers don't want to have two vendors pointing fingers at each other if something goes wrong, right? So if we sell, let's say we're going to sell you a connectivity platform, it's going to work with all your vendors. Well, if this vendor, for whatever reason, the connection is not working, we're not going to say, well, that vendor, I'm sorry, but their interface sucks, and nothing we can do about
Right.
it.
Right.
That would not be very good. So we
Yes.
take the
Yes.
ownership. Yeah, we take the ownership of the interface, and we have to work with the machine vendor, and we have to find a way with them to make it better. And so, in that sense, yes, I think we become an expert, for the machine vendors to improve their interfaces over time to make sure that this will work well. Yeah.
Final question before we go our own ways. You had a pretty good crystal ball 20 years ago, and a little bit of insight, a little bit of luck, all that. The industry kind of needed what your company was doing, and it needed it before it knew it needed it. So where do you see, put that crystal ball back to use, what do you see our industry, your company, our industry, 20 years from now, or maybe 5 years from now? 20 is Jetson's territory. The further out you go, the least accurate it gets. But what do you see the future in our industry in terms of smart factory and other things relevant to what you guys do?
Yeah, it's a tough question to answer. The one general statement I can make is that the rate of change in the world and in technology especially is accelerating constantly, right? So I think the changes we've seen in the last 20 years, there's going to be as much change in the next 5 years. That's just the way it is. It keeps going faster and faster. At some point, it's hard to keep up, right? But I think this will continue until something really big changes in our economy and the way we do things. So that becomes hard to say. Like if 20 years ago you'd ask me what's going to happen in 20 years, I would have said that's not easy to say. But there's some general trends and general direction. How fast it's going to go, I don't know. And actually, I would say that if I look back what we dreamed 20 years ago, it took a lot longer than we expected. We would have hoped to be much farther ahead today than we are. Just because of resistance to change. Again, the manufacturing industry is very conservative. You cannot bring new technology and hope for wide and fast acceptance as you would in the consumer market. It just doesn't work like that. The implications of, again, impacting your operations are just too great. So that's the nature of our industry. And I don't think that the fundamentals of that will change so much. But there is increased pressure. I mean, everybody realizes the world is changing fast. The pandemic has accentuated that all the big contract manufacturers or the big OEMs, they know that they have to accelerate digital transformation, and they have programs in place. The CEOs have told their team, hey, we need to be further and faster than we initially expected. We see that from our customers. So the pressure now will be on the technology vendors like us to be able to keep up, to deliver the technology that already exists, but to more customers and to implement that on a broader scale faster. I see that. So every company that's in a bit like us, that's into Industry 4.0 technology, will face a challenge to keep up with the demand over the next couple of years. That's what we expect. So we're preparing ourselves for that. It's not just recovering from the downturn of the pandemic. It's that, no, we're going to go to the next level of digital transformation, I think, in our industry. And how far we're going to go and how fast, I don't know, but it's going to be an exciting ride, I think, the next couple of years.
Yeah, I totally agree. I think we're in for a wild ride from pent-up demand, unfulfilled pent-up demand, and other factors. When I look at digital communication, Zoom, Zoom 12 months ago was a term used, about for cars or on cameras, right? To zoom in on something. Now it has a whole new meaning. we've had the technology around for a long time, but now all of a sudden it's completely embraced and it's now mainstream. And I think the same in your world, in connected factories, connected equipment. I think it went from, that's a great idea someday, to now people, because of the pandemic, because of lots of different issues, it's all kind of perfect stormed together, and it's becoming universally recognized as it's here and it's ready. No, totally. So I do see that. François Monette, thank you so much for being my guest today on Reliability Matters. I appreciate your insight. I really am impressed with your company's visionary skills, and you and your two other partners, your visionary skills. You definitely saw something 20 years ago that was in need, and without people really noticing it. And you certainly exceed in the fortune-telling business, more so than popular science and all the other Jetsons and things like that. So you hit the mark. So thanks for being my guest. I really appreciate it, and I wish you health and safety and prosperity into this new year.
Thank you very much, Mike. All the same to you. Thanks for having me again.
Of course. Thank you. Well, that's another episode. Thanks for listening or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on Apple Podcasts, Google Podcasts, Spotify, or virtually wherever you get your podcasts. A video version of this podcast is available on our Reliability Matters YouTube channel. Be sure and subscribe to that as well. A special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks for your questions and episode suggestions. Please keep them coming. Send comments to my email address, mike@mikeconrad.com. That's Conrad with a K. Once again, thanks for listening. Stay safe, stay healthy, stay happy, and keep doing it right.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.